So one way to solve a system of linear equations in two variables is by graphing the two lines that are represented by the equations, and then any point where they touch is one of the solutions. So you graph them, then you decide where the two lines touch, and then that is your solution. So I've got two linear equations here that are both in slope-intercept form, so we can graph them rather easily. And you'll see that when we do this, we typically put them in slope-intercept form first. Okay, so starting with the first one, your y-intercept is 1 and your slope is 2, so we're going to put it as 2 over 1 so that my rise is 2 and my run is 1. So I need to rise up 2, rise positive 2 and run positive 1 to get another point, and then keep repeating that process. And when I do that, I end up with a line that looks like this. And when you're solving by graphing, you want to be very careful to graph as precisely as possible. Use a straight edge. Because when you get your second line, you have to decide where the two lines touch, and sometimes you have to approximate that because it's not quite clear exactly what that ordered pair would be. Okay, graphing the second line, my y-intercept is 7, so 1, 2, 3, 4, 5, 6, 7 is up here, and my slope is negative 4. Again, I'll put that over 1, so I have a rise of negative 4 and a run of 1. So rise negative 4 is down 1, 2, 3, 4, and run positive 1. And you can see already that if you go ahead and graph this line, well, this point right here happened to be right on top of both lines. So that is the solution. So the solution here is where the two lines touch. So the solution to this system is that ordered pair. The x-coordinate's 1 and the y-coordinate is 3. So that is the solution. So this is a system that has one solution because they touch at a single point, and it was pretty easy to see exactly what that ordered pair was. Again, this method of graphing systems is not the best because if you don't draw your graph perfectly, you may not intersect at a nice point like 1, 3. You may have decimals or fractions, and then you won't be exact because you'll just be guessing by looking at the picture. Here's another system. I want to solve by graphing. Now I need to first put these into slope-intercept form. There are other ways you could graph the two lines, but that's my method that's my choice. So I will solve this first equation for y by subtracting the 2x and then divide both sides by 3. So to graph this, my y-intercept is a 0 out here. The b value is 0, so I go through the origin. And I rise negative 2 and run positive 3. So negative 2, run 3, negative 2, run 3, negative 2, run 3, and then I could go the other way as well, like this. And then if I connect those dots, I'll have that line. Again, we're looking for any ordered pairs where the two lines touch. So let's work on the second equation. So I'll subtract 2x. Divide everything by 3, and I end up with y equals negative 2/3 x plus 2. Y-intercept is 2. My slope is negative 2/3 again, so rise negative 2, run 3, rise negative 2, run 3, rise negative 2, run 3. And so we get a good idea now. If we connect those dots, then we'll see that the two lines are parallel, which we should know anyway because the two lines have the exact same slope. Since the two lines are parallel, they never touch, and so the solution is simply no solution because the two lines never touch. They never have a point where they're both common. Okay? One more system. The first equation is already in slope-intercept form. The second equation, I would add 3x to both sides. And so right away you should notice that these two lines are exactly the same. So if you graph them, y-intercept's 1, rise 3, run 1, rise 3, run 1. And so what you end up with is this picture where it looks like there's one line, but it's actually both lines on top of each other. And so there are an infinite number of solutions, and those solutions are the set of all ordered pairs on the line. So I've written this set builder notation for the set of all ordered pairs such that one of the equations is true. You could use either one of the equations.